Okay. Now, what is heat engine? What is heat engine? Anyone knows? Send message on the chat box also, no problem. You can send it there. Convert. Now, this is the first group. I'm asking total. That's the main objective of the heat engine. Yeah, mechanical. Okay. Okay. Heat engine is a device that converts thermal energy into kinetics. Okay. Now, okay. Heat engine. Heat engine is device that convert thermal into kinetics energy. Okay. Then what happening in that engine? Okay. Look. First thing, the chemical energy in your fuel. Okay. It's convert into thermal. Okay. Then next thermal energy is converted into kinetic energy, or you can say that mechanical energy. Okay. Now again, heat engine is converted into two parts. One is external conversion engine. One is external conversion engine, and another one internal conversion engine. Okay. Then can anyone can explain what is external conversion engine? Anyone have any idea about it? External. External conversion engine. Yeah, conversion takes place outside. Okay. Outside of your engine. It's called external conversion engine. For example, steam engine. Okay. Now, next one is internal conversion engine. Everybody knows what internal conversion engine, like your vehicles. Okay. Car, all those things. Car, bikes. Okay. Petrol and diesel engine. Combustion happening inside your combustion chamber. Okay. Now, next. Then again, here we'll focus about IC engine only. Okay. Let's go for the IC engine. This one. Now, next. IC engine again converted into two types. One is reciprocating engine, another one rotary engine. Okay. Give us anyone give me some example of reciprocating engine. Like where you have used previously, something like this. Yeah, bikes. Normally you are using reciprocating. Okay. Rotary engine. Aircrafts. Yeah, correct. Rotary engine is used in aircrafts. Okay. Based upon that, like in the piston cylinder, it is going. Yeah. It's going up and down like this. Okay. Reciprocate. Then for the rotary, here it is. This is the one example of rotary engine. Okay. Now, Next is based on mechanical conversion. Okay. First one is spark ignition. Second one is compression ignition. Spark ignition means it's required some external spark, okay, to start your engine. Okay. For compression ignition, it doesn't require any external ignition. Okay. This is the types, okay, based upon that use and all the things. Okay. Now let's start your career. Okay, always just right click and open. Okay, don't double click, triple click like this. Okay, it will take a lot of time to open. Okay. Yeah. Now, once you open your CATIA, it's by default it's open in product. Okay, you just close it, not top one, the second one. Okay. Now, anything doubts about the software only, so that I can repeat that thing or anything you want me to repeat in the CATIA V5, or else you'll directly start assembly. No. Okay. Now, so creating an assembly. Okay. Today we'll do an engine assembly. Okay. Assembly and DMA kinematics. Okay. Now, for the entering into assembly workbench, what you have to do, just go for the start, mechanical design, and assembly design. Okay. Now look, go and click in the top. Okay. This position. It's called assembly design. Okay. Now, for the assembly, if anything, okay, we are having two types of approach. One is top-down approach, and another one is bottom-up approach. Okay. Then for the top-down approach, what you have to do? Just create everything, all the products. Okay, design everything in this assembly workbench. Okay. And for the bottom-up approach, you have already done in outside. Let's say previously, let's say, let's go for the part. Okay, you've created something. Okay, now again another part. Okay, now here these two things you already created. Okay, but if you want this two in, okay, if you want to assemble this one part one and part two, okay, in such scenario you have to use bottom up approach, means already created file. Okay, you have to recall in assembly workbench and assemble the thing. Okay, is that clear? Top down and bottom up approach. Top down means you have to create everything in an assembly workbench. Let's say go for insert new part. Look, like this. Okay, you can get back to assembly. Okay, like this. If you have to create everything in this workbench, it's called top-down approach. Okay. Now, any doubt between these two, top-down and bottom-down? Yeah, publication I'll explain at the time of like. Okay, wait, I'll explain later on. Okay. Other than publication, if you have any doubt, then ask. Look, for the publication, let's add less than again here. Okay. Let's say if you want to publish this sketch here, okay, just select this sketch. Now first go for part design. Okay. Select the sketch. Go for tools. Go for publication. Okay. Yes. Look. Okay. Now press OK. Look, it's appeared in the publication. Okay. Why we are doing publication? The reason behind is, let's say here I'm having, wait, I'll open one complex part. Let's open. Okay, let's open cylinder. Okay. Here. Okay. How many sketches are there? Lot of sketches. Okay. Let's say let's almost sketch 35. Okay. If you want some specific sketch, let's say the sketch 31. Okay. For it is quite difficult to search every time. Okay, in the specification tree. Okay. First, specially mention this thing. You have to use the publication. Look. Yes. Okay. Look. Under the publication, sketch 31. Okay, you can directly double click, enter into sketch 31 also here. Okay. That's the main reason behind publication. Okay. If you want to remove this publication, what you have to do? Just again go for tools, publication, select, then remove. Okay. Then publication will be removed. Okay. Is that clear right now?
Sir, can you please repeat it, sir?
307, huh? Okay. Okay. Now, look. What is this sketch about? Okay. It is a cylinder sketch. Okay. Let's say this wall. Okay. How many sketches are there? Anyone can reply? Total almost
35.
35. Okay. If you want, let's say you're another colleague or another engineer. Okay. Let's say there is some problem in the sketch that one. Okay. How can you explain that thing? Okay. It's quite difficult, no? Okay. Let's say if you publish this one. Okay. Or else, look, select the sketch, tools, publish. Okay. Then you can easily find it out the sketch in the lower in the publication tab. Let's say click OK. Okay. Look here, publication sketch one is there. Just double click. Okay. Directly enter into sketch one. No need to go and search where is the sketch one or those things. Okay. And one more thing. Let's say tools, publication. Let's say One second. I haven't created his parameters. Okay. Okay, that thing I'll explain later. Parameter type. Okay. This is the way of publication. Okay, use it. Use means we can easily find it out for that one. Okay. If you want to further use the sketch or line, whatever it is, okay, you can directly publish it. Okay, is that clear right now? For repeated use or for easy to find. Okay, that's why you are using publication type. Okay. Now it's clear or send message or
Clear, sir.
okay. I'm closing this one. Okay, look, I'll create one like from the starting sketch to up to one like demo animations. Okay, for small like let's say for sliding one pair. Okay, then after that we will go for that engine assembly and demo animations. Is that okay? Okay. Now I don't think so. Anyone have any doubts, any problem in the sketch? I don't have anything. Any doubts in the sketch? Okay, I'll use top-down approach. Okay. For the engine, we'll use bottom-up approach. Okay. So first, what you have to do: start mechanical design, assembly design. Now it's total empty. Okay. So here, if you want to create anything, okay, it is not possible to create a model in product file, means assembly file. Okay. Anyhow, you have to go for part. Okay. So sorry for that. For part, okay, what you have to do, just go for insert, okay, new part, okay, then select the top here in the product. Okay, now one part is created here. Okay, but you are still in which workbench? You are still in which workbench?
Assembly, sir.
Assembly. Okay, if you are unable to like by looking at the tools, you are unable to find it out which workbench, just go from the top. Okay, put your mouse there, then you can find it out which workbench. Okay, now for entering into 2D, sorry, for entering into part, okay, what you have to do, just click plus, again plus, okay, then double click here, part body. Okay, now look, now you're in which workbench?
Part design.
Part design. Okay, now for creating anything in the 3D, okay, sketch is necessary. Okay, for this, select a plane, go for 2-dimensional 2D. Okay, let's say, will I use like Boolean operation or normally I can create it? Normal profile. Okay, now okay, rules. Let's give it as a 200. 50, give it 30. Hundred. Okay, remember the value. Okay, 60, 130. Okay, 60, 130. That's it. Now let's pad up to 50 mirror resistance. Okay, that's the one part. Okay, for the another part, what you have to do? Then how can I enter into part like product or assembly design? I think some of you are already completed assembly maybe in your regular classes. Okay, what is yeah? How can I enter into assembly design? Can anyone?
Sir, click on product once.
Yeah, double click on the product.
Yeah.
Okay, if you double click on the product, by default it is redirect into assembly workbench. Okay, for creating another part, again you have to go for insert. Okay, new part, select in the product. Okay, now go for plus, double click on the part body, select a plane, go for 2D. Okay, now create the profile. Okay, now look, double click for repeated use. Okay, constraint, let's give it 150. This one, how much? I think this lower than 100 I are giving, I think so. 100. This one, 30. 60. Okay, now okay, 250. Is it correct or wrong? My sketch is correct or wrong? Any response? Is it possible to remove a dimension here? Okay, this is my total drawings. Okay, send message in the chat box. Is it possible to delete like 250 or else upper one and lower one? Anything? Correct, yeah? What's the remaining?
If we want, we can also click on the constraint for this vertical lines.
Yeah, correct. Okay, look, give to for a rectangle. Okay, for opposite side, you don't have to give the same dimension again. Okay, so always try to create using geometrical constraint. Okay, so select this line, convert into vertical. Okay, now it's done here. Exit. Okay, not bad. How much? 50 mirror restraint. Okay, now double click. Okay, now I want this must be slide here. Okay, so if you create any profile or any model, okay, how many degree of freedoms are there? Let's say for this one, okay, for part one, how many degrees of freedom, sir?
6, sir.
What's the remaining? What are they?
X-axis, Y-axis, Z-axis. Rotation about X-axis, rotation about Y-axis, rotation about Z-axis.
Yeah, 3 rotation, 3 translation. Okay. Now, if you want to slide only, okay, let's say Y, okay, in Y direction, okay. The remaining thing you have to like restrict the motion. Okay. So what you have to do here? Anyone? Okay. Look. Let's say you are having 2 parts. Okay. Look, here are some tools are there. Okay. Manipulation tool is there for rotate or Y. Okay. Now look, I'm having 2 parts. Okay. But the first basic thing is always you have to fix. Okay. Look, base always fix. Okay. So click here the fix component, select the first one, then it is fixed. Okay. So there is no movement for this one. Okay. For this one. Okay. I need this must be translate again Y axis. Okay. And exactly from this point to this point. Okay. So what you have to Subramaniam, any doubts? Now, let's say okay, I want this one, this one. Okay, must be in same line. Okay, which type of constraint I have to use? Like offset, okay, coincidence, contact, angle. Okay, what type of geometrical constraint I have to use? I want this two must be in a straight line. Okay, anyone?
Right line, sir.
Means this two. Okay, let's say I'll move little bit. Let's move in chat. Okay, not Z, X. Okay, I want this two surface. Okay, faces must be in a single. What say you can say single plane. You can say like this. Okay, what I have to apply? What type of constraint?
Coincidence, sir.
Coincidence. What's about the remaining? Now you have to apply offset. Okay. Okay. Here, which one you have to choose? Moving part or fixed part?
Moving part.
Correct. Moving part you have to choose the first, then fixed part. Let's say give 0, enter. Okay. Now the black color means anyone have any idea? What does this color means? Black color. Black color means you have given constraint, but it is not updated. Okay. For this, you have to click Control U for update. Okay. Control U. I think the symbol is somewhere here. I think everyone knows about Doordarshan symbol. Huh? Okay. That's the symbol of update. Okay. Wait, I'll customize. Okay. Look, if you are unable to find any tools, anything, okay, you have to go for customize tools, customize, or else here right click and customize. Then go for toolbars, restore all content. Then restore position. Then press OK. Close. Where is- Yeah, here it is. This one. Okay. Let's edit this thing. Let's give set value 5. Okay. Look, this symbol. Okay. Click. Then it will update. Or else Control U. Okay. Now, what next? I want, look, this face and this face. Okay. Must be touched. Okay. Which type of like constraint I have to use here?
Contact. Surface contact.
Yeah. Contact constraint. Okay. That's this one. This one. Control U. Okay. But then again, these two same. Okay. Now Control U. Is that clear now? Sorry. Change this one 0. Okay. Any doubts till now? Okay, this is the way you have to assemble. Okay, based upon your requirement, you can give angle, coincidence, all this thing. Okay. Now, once your assembly is done, okay, you have to go for the DMU. The DMU full form is digital mockup. Okay, means that you will check how your model is moving. Let's say piston cylinder rotation, movement, how it is moving. Okay. For this, what you have to do, go for start mechanical design, sorry, digital mockup, then go for DME kinematics. Okay. Now here for kinematics, okay. One thing is required. It's called mechanism. Okay. So for this, first what you have to do, for the first one, to moving anything, always go for fix your base. Okay. Now we don't have any mechanism. That's why directly create new mechanism. If you want to give name, just give name or it's okay. I want to fix this one, first one. Okay. First one is fixed. Now the next is I want this must be moved like this. Okay. Now I'm having lots of types of joints. Okay. So for sliding, which type of joint you can use here? Anyone have any idea? For sliding, prismatic, correct. The industrial fix command. No, it's only for that for constraint purpose only. Look, if you haven't applied fix, okay, then we can't use like mechanism. Okay, without fix, mechanism cannot be used. Okay, always you have to fix your base. Okay, is that clear? Like what number? D naught. Okay. Now go for the prismatic. Okay, here you have to choose line 1, line 2, plane 1, plane 2. Line 1, line 2 means in which line it will be slide. Okay, let's say from this one, first hide this one. Okay, this is my line 1. Okay, go for hidden space, line 2, plane 1, plane 2. Okay, then you have to click a length driven. Okay, means we are giving value for the rotation, like for movement. Okay, lengthwise. Now look, if mechanism can be simulated, pop-up window is open, which means you can simulate that thing. Okay, I'll just unhide. Okay, now for the checking purpose, here one tool is called simulation with commands. Click. Okay. Okay. I don't need this one. Okay. Crossing here. So give it lowest value is 0. Now press OK. That's it. Okay. Now close. This is one type. Okay. If you want to move continuously, okay. For this, you have to go for simulation. Okay. The toolbar name is DMU generic animation. Okay. Go for simulation. Look, if you're having a lot of mechanism, you have to choose in which mechanism you want to play. Select the mechanism. That's okay. Look, just move once, insert, then the loop, single time or up and down, or else repeatedly same thing. Whatever required, you can put it here. Then reduce the time, then press OK. Sorry, it's continue loop. Okay.
In which workbench you are working, sir, currently?
Sorry.
In
Which
which
workbench?
workbench? Yes.
This one, a digital mockup.
Okay,
Kinetic
sir.
map. Look,
Static
you have to
analysis.
go
Okay, sir.
start digital mockup, then DMU kinematics. Okay.
Okay, sir.
For engine, I'll explain again here. Don't worry about it. For the engine, we are having. Okay, let's say if you want to simulate your engine, means piston cylinder, that one. Okay. Okay, which type of joints you can use there? Can you have any idea? Let's say okay. What is that? It will go up and down like this, no? Okay. Here, which type of joints you can use?
Sliding joint.
No.
Revolutionary joints and prismatics.
Revolute joint you can use the blower. You'll use cylindrical joint, okay? Something called cylindrical joints here. Okay, we'll start now. That engine assembly and demechanics, okay? Any doubts here? Anything you want to repeat from here? No doubts, sir. Shall we go for the next?
Sir, after fixing the component, you just added one
further tool also that one.
Your voice is not clear. Send in message. After fixing component, next operation. Look, in DMU kinematics or assembly workbench? Assembly DMA. Okay, after fixing, okay, anything. Okay, you have to go for that joints. Okay, which type of joint is used? Okay, look here. After fixing this one, okay, this is my base. Okay, I've gone for prismatic joint because for sliding it's called for prismatic joints. Okay, that's why. Look, like once I completed your engine DMA kinematics, it will easy to understand. Okay, it will easy for you to understand. Okay, just wait for it. Anything else? Okay, we'll go for the engine.
Sir, are we doing this top-down approach?
Yeah, this is top-down approach.
Okay.
Explain joints. Which type? Like you need all the joints, huh? Or on any specific joints? (26) all. Okay, you can send message okay for that one because if I explain for the all the times like this there's some time constraint as well. Okay. Okay, if time is there at the last, I'll explain all the joints. Okay. Now, new assembly. Okay, we'll start engine assembly. Okay. Okay, can you someone explain me what are the parts are available in the engine? Most probably, like piston, cylinders, and parts.
So piston, connecting rod, and
Hmm,
Piston,
Crankshaft.
yeah, correct.
gasket, surgeon pin.
Okay, we'll create engine DMA kinematics. Okay, but whatever the use in that mechanism we'll use create. Okay, for the remaining thing which is not used in the mechanism, we'll skip that one. Okay, let's say first, which one we'll call first? Look, previously what you have done, just right click or else click your insert and new part. Then after that you have click in the product workbench. Okay. Now for the next thing, bottom up approach. Okay. Here your file is already saved. Okay, somewhere in the file in your system. Okay, you have to recall that one. Okay, for this thing you have to
Existing component positioning.
correct. No, I don't need which position. It depends upon you. Okay. But in such case, in this scenario, I don't need which position. Okay. So here the two thing existing component. Next is existing component with position. Okay. If everything like what I said the previously, like you have created in the like top-down approach and deleted something, then again recall that thing. In such scenario, you can use existing component. Wait. Look what I have done here. What is this thing? it's it's 100 ml, okay, from your vertical axis, okay, which means where the previous one is finished, okay. If your model is created like this, then you can use directly with positioning, okay, but easy for the constraint, or else you can directly click existing component, okay, then click in the product, okay. Now let's go for the desktop, okay. Now look, here engine is not directly assembly, okay, it's a main assembly. Inside engine you are having some sub assemblies file, okay. For this, let's first call a look piston and piston pin, okay, just assemble these two. So in the future, at the time of like applying constraint, it will easy for you, okay. So directly call these two, open, okay. For this one, piston and piston pin, okay. Then what I have to do here? Anyone have any idea? Which type of
Coincide constraint to piston pin and
correct? 304. What are you trying to say? Access constraint? No. Okay. Just go for coincidence constraint. Which one you have to choose first? The moving part. I want this thing move. Okay. Select this. Then okay. This. Okay. Is that okay with you? Now leave it like this. Okay. Don't apply fix anything. Okay. Because this one is comes under a sub assembly. Okay. Then go for just right click in the product to properties. Okay. Piston and pin. Okay. Now click Control S. Save the file where okay where you want your like I think my desktop is visible to all of you.
Yes, sir.
Look, I call all my file from ENG folder, this folder. Okay. So if you want to save your product, always save in the same folder. Okay. That's the requirement here. Okay. If you save in other places, it will be quite difficult for you. Like again, further reopening the files. Okay. And one more thing, if you want to save your file to anyone, okay, say all the file at a time. Let's say all the assembly in this folder. Okay, you have to save all the file, not only this CATIA product file. Okay, CATIA product file only keeps your links and connection, not the like CAD model. Okay, is that clear? Yeah. Now, what next? Start another assembly. Go for existing. What? We'll use connecting rod. Okay. Open. Now this one, right click, properties. Okay. connecting rod assembly. So where's the other parts? Look, for the movement, we're having this one, manipulation. Okay. Now, what you have to do here? Can I explain? This one. Look,
Contact constraints.
no, no
Rotate
contact.
and align with the connecting rod.
Yeah, align with this hole. Okay. Look, this one is like this. Okay, but you need in the other direction. So for this, you need rotation exactly 180 degree. Okay. So look, which one exactly in the middle? X-axis. Look. Now is it clear? Which one in the exactly middle? X and Z. Okay. So go for manipulation. Look, rotate along Z axis. Or X, whatever you want. Okay, is that clear right now? Yeah. Now, click coincidence, moving part, this one, width. Okay, now it is not updated. Okay, now again, this one. Width, this one. Now go for Control U or else click it here. Now, is that okay? Is it completed or not?
Yes, sir.
No,
No, sir,
it's
not
not
fully
complete.
constrained, sir.
Correct.
Small gap
Why?
is there, sir. Gap is there, sir, in between.
Not small gap. Okay, you are given coincidence with this two and this two. Okay, but look here, look, click it here with respect to constraint. Okay, now which direction? Z. Okay, delete this text. Just for movement, okay, because it's already in contact now, that's why it is not moving like this. Okay, but actually there is some gap. Okay, so here what you have to apply?
Offset.
Yeah, offset.
Contact constraint.
Okay, first select your moving part, then 0, enter. Update. Now it's done. Okay,
Or is there any option to know whether it is fully constrained or not?
you have to check it by yourself. That thing you can know in DMU, not here. Okay, Now Control S again. Okay. Look, I've taken all the file in ENG folder. Okay. Save in the same folder. Now go for again start. Okay. Now just rename this one. Properties. Okay. Now which one is called fast? Let's call crankshaft. Okay. Crankshaft. Okay. Now, is it possible to fix crankshaft?
No, sir, it is a rotating part.
Yeah, correct. So again, call. Which one? Cylinder. Okay. We can fix this one. Okay. The cylinder is not a rotating part. Okay. Now go for fix. Select this one. This one is fixed. Okay. Now just I want to rotate this one. Okay. Allow. Go for manipulation along the direction. Which one in the middle? Let's say X. Yeah. Now with the movement Y. Yes, okay. Now, what's the relation between these two?
Sir, concentricity.
Coincidence, sir.
Coincidence. Okay. Select coincidence. First select which one? Crankshaft or cylinder?
Crankshaft, sir.
Yeah. Then okay. Control U. Is this okay or not?
Not it, sir.
Because look, here it is intersecting. Okay. So move this one in the top. Okay. Now is this okay? It's not intersecting anywhere. But still, this gives some offset here. Moving part, fixed part. How much? Keep it like this. Okay. Okay. Is there any problem? Means any doubts?
Sir, how are you seeing that y is in the middle, z is in the middle?
Using this compass, this one. Look, if you rotate like this, no? X. Look, if you rotate like this, okay? If you want, let's say you want this direction, okay? Whatever that, this edge, okay? Just rotate. Now look at here. Which one? X. X is downward, Y is sideward, and by default, Z is vertical one. Okay. Let's say for the crystal, okay. Move it. Well, okay, let's move this direction. Okay. If you want to move along this, is my mouse is visible or not?
Yes, sir. Yes.
Okay. If you want to move like this direction, look here. Which one is that? Z. Okay. Like
Yes,
this, you have to find it out. What is the direction of your like X, Y, Z or the, okay?
Sir, for direction of rotation, we should see the middle one.
Mhm.
For direction of rotation, we should see the middle one.
I didn't get it. Which direction?
If you want to rotate a component, we should see the middle one.
No, no, no. Let's say if you want this one, okay? Crankshaft, exactly 180 degree. Okay. Now what you have to do? Let's see in the middle. Here, Y. Using Y, you can rotate directly.
Okay, sir.
Okay. Now okay, this dimension is this one. You have to add it. Okay, first calculate distance from here to here and all this thing. Then you can put it there. Okay. Now next, we call which one? Let's call crank this connection. Okay. This one. Okay. This must be put it here. Okay. So what you have to do here directly? What type of constraint you have to apply? I think it's visual this one. Huh? I think this one. Okay. This one must be touch here. Okay. What you have to do here? Which type of constraint? Contact. Yeah. Contact. I don't think so. Offset is better in this scenario. Then what's up the another one?
Coincidence.
Correct. Coincidence. Okay. Now, where's the coincidence? Okay. Select this one first. Okay. Now, control where it is on. Okay. This one. Now, offset. This one. This one. How much? Give 0. Update. Now again, this face and this lower face. Okay, this one. This one. Okay, now control U. Now, is that clear? What I have done here. Look, coincidence. Okay, this connection part axis and this crankshaft axis. Okay, now from this side and this side. Okay, contact means zero offset, and this lower one, zero means contact touch. Okay, is that clear right now? Okay, now for the next 1, 2, 3, 4, remaining 4. Okay, for the remaining 4, use multi instances. Okay, now submit Control Z, click. Second one. Okay, select the crank connection. Okay, here I think everybody knows about like what's it pattern. Okay, now how many needs? 1, 2, 3, 4, except the last one. Okay, now spacing. How much the spacing? Okay, give it like this. Okay, let's say if it is okay, this one is for result. Okay, that's a 0, the straight. Okay, look, Z direction. If you want this one, Y. So here change into Y, then Z is 0. Is that clear? Look, close it. Just click it, define multi instantiation, select your part. Okay, then give instances how much. Okay, means how many, then spacing, then give the direction, then press OK. That's it. Okay, now what next? This one is already defined, but this one is not defined. You have to give again dimensions here. Now this one, this one, now offset, this one, zero, okay. Now again offset, Okay. Okay. Okay, like this, you have to create the remaining thing. Okay. Okay, I'll skip this thing. You can create yourself. Okay. Is there any doubts bit like how to assign the client connection? Can you create instances the language constraint? Yeah, we can create. But I don't know the dimension. That's why I haven't created. Wait, I'll complete in as soon as possible this one. Okay. Achha. Okay. Now, okay, you can choose the top one also, not problem. Okay. Zero. Now, within this two, 10. Zero. Update, control E. Okay. Is that clear? Any doubts here? Now, call the next part here. Again, which one? Okay, consider endpoints. Okay. Just select. Look here, another option also there. Just click and drop, rotate. Okay. Now, what I have to do here? Yeah, correct. Coincidence. Okay. Coincidence. Okay. Now next is offset. Okay. Now control U. Now again. Yeah. I think it's done. This one. Just give me 1 minute. Okay. Now, next. This will hide it. Okay. It's not necessary now. Now again call. Sure. The best part. Okay. This one. I need it in this direction. Okay. So just drag, drop, and rotate. Okay. Now what you have to do here. First, other than cylinder, okay, hide everything. Okay. Now apply. What will apply here between these two? Correct. Not going through. Offset. This one. This one. 0. Moving down. Okay. Double click on the offset. Moving part. Now again. Okay. Now I think that's done. Any doubts? Then on hide remaining thing. Uday. Any doubts? Okay. What next? Hmm? We'll call connecting dot. Okay. Okay. So what if apply between these two? Coincidence. This one. This one. Update. Now Yeah, you can use directly upside also, no problem. Between okay. Now what next? That bearing is not created. Now next, call another one. Okay, follow the same process. Now keep the gain upside. So now what you will do? Anyone? Look, the cylinder. Okay, this is a connecting dot. So what you have to do here? Anyone? Define multi. No. Look, both are here. Okay, but the position is different. So you have to rotate here. Yeah, manipulation toolbar. Bring piston and points with a small end of the piston. No, first arrange this one, then go for the piston. Okay. Now select Okay. Now it's okay, almost equal. Okay. Look. Okay, it doesn't matter it is perfect timing or not. Okay. Now, what next? Call Estelle. Estelle and pin assembly. Okay. Now, okay. Now what will do here? Use coincidence. Okay. This access. This access. Update. Now, again, coincidence. This one. Okay. Same thing. The concept already created now. So don't worry about it. Okay, we'll do DME elements only this two cylinder. Okay. But the remaining thing you have to try yourself. Okay. It will take a lot of time if I started to draw all 1, 2, 3, 4, 5, and remaining 10. Okay. Now next again call okay. No, mirror is not possible. Why? Can anyone can explain? Why mirror is not possible? Here. No, there's nothing like this. Look, check the position. Here one piston is here, another piston is top. That's the region. Okay, if both are in the same position, then only you can mirror. Okay. Look, if you mirrored it this one, it will appear there, not in the top. That's the problem. Okay. Now apply. rotate fast this one. Then move up. Okay. Then apply. Now again okay. Now look, remaining thing you have to create yourself, okay, using the same process. Okay. Now we'll go for kinematics of these two cylinders. Okay. So for this, go for start distal Markov kinematics. Okay. Now which one you will fix here? Click fix, new mechanism. Okay. Yeah, cylinder. Now between these two, what I will apply? Apply rigid. Okay. Because between these two, there is no movement, nothing. Okay. Now, next, just hide the scatter. Now, between these two, which type of joint? Cylinder and crankshaft. Rotation. Revolute. Not rotation, but it's okay. Now, go for revolute. Okay. This one. Then hide it. Okay. Now, plane. This plane. this one, angle driven, offset, because look, if you haven't given null offset means it will move towards this end. Okay, so give offset, then press OK. What is this? Mechanism can be simulated. Okay, which means it will rotate like circle thing. Okay, circular movement. Now what next? Between these two, again revolute joint, double click revolute if you want to use repeatedly. Okay, okay. Now surface. Hide the cylinder. Okay, to the space, to the space, offset, no angle development. Okay, now again go for this top one. Okay, offset. Look, now I have applied relation between this lower one, this top one. Now this side. Okay, remember. Cylinder this side. Yeah. Now apply cylindrical joint. The top one. Now the mechanism can be simulated. Prismatic. Which one is prismatic? No, that one is cylindrical joint. Now the next one. Apply cylindrical joint. This top one. Hide this one. Okay. Now again hide this thing. It's not required. Revolute joint. Okay. Offset. Now this one is given. Now give this lower. Okay. Offset. Okay. Now the mechanism can be simulated. Look, I have completed this two cylinder. Now this unhide. Piston. This scatter. Okay. Now let's play this animation. Go for mechanism. Okay. Okay. Now click insert. Continuous. Okay. Now play. Okay. Now just unhide the cylinder. Look, one side open, another side is closed. Okay. The remaining piston and cylinder, all those things, not cylinder, piston, crankshaft, you have to apply yourself. Okay. Any doubts? I have selected top phase for the question. I didn't understand what you said. What is top phase? Okay, you can open your mic and ask, no problem. For what purpose? You're asking for selection of top phase means what purpose of the selection?
By giving these joints, you have selected the piston crown, no, sir. I did not understand the purpose of.
That one I've used like cylindrical joints. Okay, I haven't selected anything. I have just selected the middle axis of the piston. Okay, and middle axis of the cylinder. That's it. For the piston, I use only this two only. Nothing I have touched. Because why it is going up to this top one? No, this depends upon this crankshaft. Okay.
Okay.
I don't have any doubts. Okay. Okay, we'll wind up the session.
Yes,
Yeah.
we'll wrap up the meet.
If anyone have any doubts, that you can ask tomorrow also. Okay.
Thank you all guys for joining today's session. Thanks Rakesh for presenting today. We'll wrap up the meet now.
Sir, how do we get these recorded videos or something? Fine.
Oh, you will receive by mail. You can directly ask, like, which college you are from?
Narsabad Engineering College.
I think trainers is there, no, in your college. You can
Yes,
ask.
sir, yes. Okay.
You can ask a trainer. Okay.
This
I
session
think
is recorded
Abhilash
videos,
told
sir.
that. What? No, yesterday Abhilash told that after completion of the workshop every day, they will get the video, means by end of the
No. By after completion of this workshop is complete. After this week, they'll okay.
Okay.
They'll compile all the videos, then they will send it back. Okay. If you haven't received any like any video or anything after this week, they can directly call. Okay.
Shall I end the meet?
Yeah.
Yeah, thank you guys.
Yes, sir.